Hi everybody, and welcome to this wonderful session as part of 24 Hours of Pass by Guy Glanter from Madeira Data Solutions. My name is Ami Levin, and I'll be moderating this session, meaning I'll be the one that listens to your questions and helping you throughout this session if you have any technical issues. Before we let Guy start, I would just like to go over a couple of technical issues and a couple of thanks slides. So as you probably noticed, you're all muted, so you can't, well, you can speak, but we can't really hear you, which means that if you have any questions, please locate the chat window at the bottom of the GoToWebinar panel on the right side. There you have a chat box and you can type in your questions, and I'll be there to answer you. At the end of the session, Guy will have a few minutes to answer your questions. So don't worry, I know you're going to have lots of questions and you're going to be very anxious to hear the answers. Just be patient. Guy will have time for that at the end. We also ask that at the end of the webinar, please fill out the short evaluation. It'll help us and Guy make it even better than the excellent that it's going to be this time. So Guy, next. Yeah. All this would not be possible without our sponsors. So we have our presenting sponsors this year are Microsoft, Idera, and Attunity. And we also like to thank HP Enterprise and SQL Sentry supporting 24 Hours of Pass. As you know, Pass is a nonprofit organization that offers many training and events related to SQL Server Data Platform. If you're not a member yet, that's the time to go to sqlpass.org and sign up. There's an abundance of resources that can help your career skyrocket with everything regarding Microsoft Data Platform. So next, yeah, and we have the summit coming up. And if you've never attended the summit, well, if you've attended the summit, then you probably know you can't really miss it. If you haven't, then you have an opportunity to save $200 now using the discount code that appears on your screen. It's the world's largest data platform conference. Amazing technical sessions, get to meet the SQL dev team. It's just mind-blowing. So don't wait, because I think there's really only a few spots left, so whoever grabs them first wins. Let's move on, and yeah, I think I'll let Guy talk about himself. I've known Guy for many years and he does that better than anybody else. So Guy, go ahead.
Thank you very much, Ami. It's a great honor to be here, and it's also a great honor to have Ami as my moderator. So my name is Guy. You can see my details over here. I am the CEO of Madeira Data Solutions. We're a company that provides data solutions and services, mainly around the Microsoft Data Platform and SQL Server specifically. I'm a data platform MVP. I write a blog. You can see it here. I speak in all kinds of conferences and events around the world. One of them, of course, is Pass Summit, and here also. I also run a podcast about SQL Server. It's called SQL Server Radio. So if you're not familiar with it yet, you should. So go to sqlserverradio.com. Me and Matan Jungmann, my colleague, we talk a lot about SQL Server stuff, events in the community, everything around SQL Server. So much about me. And let's talk about the session. So the session today is called From XML to JSON, and I'm going to talk about these two data formats or languages, or there are all kinds of names, we'll talk about it later, and how they are supported in SQL Server. So first, we'll introduce XML and JSON and talk about what they are. A lot of people tend to compare between those two things, while some others might say that they are not even comparable. So we'll talk about that. We'll see what's common to XML and JSON and what is not. And of course, what SQL Server has to do with it, what kind of support we have for XML and JSON within SQL Server. I think it's very important to talk about the right use cases. When should we use XML or JSON in SQL Server, and when should we not? And of course, demo. This is where we're going to spend most of the time of this session. So, XML stands for Extensible Markup Language. JSON stands for JavaScript Object Notation. And they are both mainly used for exchanging data between applications and systems, and also storing data in all kinds of data platforms and technologies. These are the main users for these two data formats. And let's just take a short example. Here is an XML document. This is how an XML document looks like. So we can see tags and elements and attributes. We can see here that it has nested levels, so we can represent hierarchy with an XML document. And if we look at all the elements, so this is the root element of our XML document, orders, and we have another element here, the customer element. This is an attribute. We can specify attributes within each element. In this case, it's the order amount attribute and its value. And we can also specify a value for an element, not just for attributes. So here we have the element value for the comment element, and so on and so on. This is the idea. This is how an XML document is represented. A JSON, this is a JSON object representing more or less the same data as we saw before in the XML document. The syntax, of course, is different. We have some different notations, but the general idea is the same. So here we have an object. This is how we note an object. And within an object, we have pairs of keys and values, key-value pairs. So here is a key. And the value can be either a scalar value, it can be a nested JSON object, and it can also be an array of values or objects. So in this case, we have an array. This is how we note an array. And inside the array, we have another nested JSON object with the key value pair of customer ID. Here is the value, of course, and then we have another key, and the value is another array, and so on and so on. So this is a JSON, an example of a JSON object. Now let's compare between them. So first, what do they have in common? Both of them, XML and JSON, are both well-documented open standards. They've been here for many, many years. XML have been here for much more than JSON. JSON is relatively new, but both of them are open standards, very commonly used and adopted by many developers and platforms. They are both text-based, which also means they can be fetched with HTTP request, and everything that goes with it. It makes it more easy to work with the firewalls and stuff like that. And they are both self-describing, as you could see before. It's quite easy to read for humans to read XML documents or JSON objects. They have the element names and attribute names and the keys. It's quite easy to follow and understand what the data represents. And of course, they both have hierarchical representation. Natively, we can represent an hierarchy with nested levels. And maybe the most important thing is that they are semi-structured. Compared to a relational database where we have structured data, both of them are semi-structured data formats. And it means we can specify dynamically different keys and values or elements and attributes, and we don't have to predefine the structure strictly as we do in a relational table, for example. The last thing that is common, they are supported by many programming languages, and there are many, many parsers out there for XML and JSON. So it's very easy to work with both of them, whichever programming language you work with. Now, what are the differences? So there you go. XML, as I said before, it's quite old. It's been here for many years. JSON is relatively new, still been here for many years, but relatively new to XML. And it's considered more sexy. Developers tend to like JSON more these days and prefer JSON because it's the new kid in town. Being more older, XML is more mature and widely adopted, but really JSON is catching up really fast. It's very common to use JSON today in many, many platforms and applications. One big difference between them is XML is actually a language. It's a markup language. It means we can use transformations We can have schema definitions. We have a lot of benefits and features that we don't have in JSON. JSON is merely meant to be a data format, to represent data. So this is one big difference. Although in practice, a lot of developers use them the same for, again, for storing data, representing data, and exchanging data between applications. XML is more verbose than JSON. We have all the opening tags and closing tags and the names of each element and attributes, so it contains more text than JSON. Some people think that it performs much better because it's, JSON performs much better because it's lightweight. From my experience and from others, it's not such a big difference in terms of performance between them. Maybe other things will make a difference, but not the length of the text. XML requires parsing. JSON might also require parsing, but if you work in JavaScript, which is the common usage, then JSON is native to JavaScript. A JSON object is an object in JavaScript. You don't need a parser to extract data or to convert data from JSON to anything else to represent it in JavaScript. You just use it as it is. So this is a big advantage for JavaScript developers to work with JSON. And there are all kinds of other different characteristics between them. For example, JSON supports arrays natively. You can represent arrays or collections. XML doesn't. You can represent arrays within XML, but it's not native. So there are all kinds of differences like that between them. These are more or less the differences. Now, what SQL Server has to do with it? So in SQL Server 2K, many years ago, this was the first time Microsoft offered support for XML. It wasn't yet an XML data type, but we could convert from relational and from relational to XML in SQL Server 2K. Then in SQL Server 2005, Microsoft introduced the XML data type, which offers still today a lot of functionality through CLR methods, also namespaces support and schema definitions, schema collections, and XML indexes. We got a lot of support for XML natively within SQL Server since 2005. Nothing really happened since until SQL Server 2016, where we now have JSON support. The JSON support we have today is quite similar to the XML support we had in 2K, because there is no JSON data type. We don't have a native JSON data type. JSON is represented as text, as nvarchar max, for example, in SQL Server 2016. But we do have all kinds of functions and features that we can work with JSON data inside SQL Server. And of course, we'll see that later in the demo. So let's go through the features quickly. If we want to convert from a relational data set to an XML format, we use the for_XML clause in a select statement. We have now the same for JSON. It's called for_JSON. If we want to do the opposite, to convert from, to extract relational data from XML, we can either use the openXML function or the nodes method of the XML data type. And with JSON, we have the openJSON function. Again, XML is a native data type in SQL Server. JSON is not. It's represented as text. We have CLR methods for all kinds of functions working with XML data. For JSON, we have some new T-SQL functions we can use. XML also support namespaces, XML schema collections, and primary and secondary XML indexes, where JSON does not. Now, before we go to the demo, I think, again, it's very important to talk about the use cases. So there are a couple of use cases why we should use XML or JSON in SQL Server. The first one is when we need to store semi-structured data. Okay, so for example, we have a client who has an online gaming platform, and they have all kinds of games. They have a game results table where they store the results. This is a relational table in SQL Server. They have the player ID and the bet amount, the profit of that game, the game type, of course, the timestamp and stuff like that. But they also want to store information about the specific game. There are all kinds of game types. So for each row, they need different information about the game. The structure, the schema of the data representing the game is different for each game. So of course, they could go and design a relational structure for each one of those games. There were around 20 game types. But this would require a lot of work, a lot of development and maintenance. And in fact, all they needed is to store that information and retrieve everything as it is later to the application. They don't need to query it and analyze it in the database. So it's much easier and much more convenient and fast in terms of development to use another XML column in that case, or it could be just as well a JSON column, to hold all the extra information related to each game type. And then for each row, we can have a different schema within the XML document or the JSON object. So this is one use case. Another use case is where we have changing data structure. Okay, this is another angle of the semi-structured data. Semi-structured can also mean that the format can change, the structure can change over time, and we don't want to predefine the structure at the beginning. We want to leave it semi-structured. Semi-structured is because XML and JSON, they still have a general structure. Okay, you have to follow the rules to have a valid XML or JSON object, but you don't have to specify in advance which fields, which elements or objects will be contained within the objects or the documents. So this is something that can change over time, and it's very easy to develop a system using these notations. Next is when you have to integrate. If you have an architecture where you have both MongoDB and SQL Server and you have to transfer data between them, MongoDB, just as an example, stores everything as JSON. So it's very convenient to have JSON support and to be able to perform JSON functionality on data in SQL Server when you have to move data around. And the same goes when you have integration with web services and applications that work with XML data. Same idea. Another use case, well, this is maybe not the best choice, the best reason to choose XML or JSON, but there are all kinds of T-SQL tricks, things you can do to manipulate data using the functionality provided by XML or JSON. One example is to use for XML paths to manipulate data to convert a set of rows into a single value with delimiters. It's very common. You can find all kinds of examples like that on the net. I've also seen several parsers, T-SQL parsers using JSON functionality, which might be interesting to try. But again, this is a nice thing to play with, but not the main reason to use these technologies. And the last thing is, if you already work with SQL Server and you have the skill set and you have the tools and you have everything that you need in order to efficiently work with SQL Server, and now you need to work with a NoSQL platform, so you need to support semi-structured data. Maybe the best choice would be to use MongoDB, just as an example. Okay, but there is a learning curve, and you have to invest, and you have to find the right people and to train them, and it has cost. Okay, so you need to evaluate, and in some cases, it might make more sense to use the support that offered by SQL Server to work with JSON in SQL Server, and not necessarily go to MongoDB, even if it's not the best choice professionally speaking. Okay, maybe it will not give you the best performance or the best development experience, but it will still be a better choice business-wise. Okay, so you need to consider it. And of course, I've seen a lot of cases where people use XML or JSON the wrong way and for the wrong reasons, like working with XML everywhere in the relational database, or querying XML or JSON heavily. This is not things that a relational database like SQL Server is meant to do. Okay, so we need to consider when to use and how. So, enough talking, let's go to the demo. All right, so I'm using, of course, SQL Server 2016. And first, there was a relational query. Okay, so I have here a select statement. I'm using the AdventureWorks database, and we have a simple join between the customer table and the sales order header, which gives me all the orders of all the customers, specifically all the orders higher than 10,000. So here it is. Not very interesting. This is the data set. And now I want to convert this relational data set into an XML document. So what I can do is just the same select. I'm just adding 4 XML row at the end. There are 4 modes of 4 XML. We have 4 XML row, we have 4 XML path, we have auto, and we have explicit. Okay, I'm going to start with row. And by just adding for XML row, I now get the result as an XML. Okay, it's still a data set, but only one column and one row, because the select statement always has to return a data set, result set. But now, thanks to Meta Studio, we can click this, and it opens in another tab. We can see here the XML document. Okay, so now what for XML row does, for each row in the original table, we get an element with the generic name row in the XML. Okay, so just a bunch of elements, and each column in the result set is translated into an attribute in our XML document. Okay, so this is how it looks like. Very simple. No hierarchy and no nothing yet. We can play with it. We can have some additions. For example, we can add the root element. Okay, right now we don't have a root element. We can have a root element with the name orders. So it will look like this. Okay. And now we have, this is actually a valid XML, because a valid XML has to have a root element. We can also add a different name for the basic row. Instead of row, ROW, I can call it order, because each element represents a single order. So now it looks like that. Okay, so it's more readable, which is great. And the last thing we can do at this point is, instead of having all the columns as attributes, we can have them as elements, sub-elements. So I just specify elements, and now it looks like this. Okay, so we have the orders, and then for each order we have sub-elements, one per column. So we can choose either attributes, which is the default, or elements. This was for XML row. Now we can also use for XML path. Okay, I'm going to use the same name for the basic element and the root element, just as before. But now with for XML path, we have to take care of the column names. For XML path uses the column names in order to construct the XML document. So what happens here? This name, okay, the @ sign represents an attribute. So what I'm saying is, within the main element, the order element, represent this value, this column, as an attribute with the name customer ID. This represents the element value. So the value of the main element will be the sales order ID. Order date time, when it's specified like that, just as a name, this is going to be a sub-element of the main element. And this one is going to be an attribute by the name of value within the sub-element order amount. Okay, so let's look at the result. So there you go. We have the root element, the main element order. We have customer ID as an attribute. This is the sales order header ID as the element value. We have order date time as a sub-element. And then we have another sub-element, order amount, within with an attribute within it called value, okay, which is the amount. Okay, so we have more flexibility in constructing the XML with for XML path, but we still don't have hierarchy. Okay, we can describe maybe some of the columns as sub-elements, but it's not real hierarchies yet. But at this point, it's time to talk about JSON. So just as we have for XML path, we now have for JSON path. Okay, so let's add for JSON path. Now the names are a bit different. Okay, so now we have each one here represents a key. So we have the customer ID key, the order ID key, and if we put the dot here, this means we have the key order, and within it we have a nested key, which is the order date time. We have actually an order object, and within we have the order date time. Let's see how it looks like in JSON. So we get again the same idea of one column, one row, one cell with a JSON. Meta Studio still gives us the hyperlink functionality to click it, but unfortunately, it doesn't look as pretty as XML. So it doesn't format it. Meta Studio doesn't format the JSON object for us. It's just one row of text. And here we can see that we start an object. We have the orders, which is the root element, like we had in the XML. And now we have an array of objects. Each object has the customer ID key, and we have the order ID, and then we have the order, which is inside we have a nested object with the order date time and the order amount. Okay, just as we specified here. Now another thing about JSON, by default, null values are not included. Okay, this is part of being semi-structured. This is true for JSON and also for So if I add here the comment column, which has mostly null values, we can see here, you can see that comment does not appear anywhere, okay, in any of the objects here, because there are null values in there. But we can add include null values like that to the for JSON clause, and this will include, of course, the null values, if that's what you want. So now we have the comment attribute with null. Another thing, if we remove the root clause, okay, just for JSON path, then we don't have now the external object which was which had the key orders, okay. So now it's just an array of objects, a collection of objects. We can also, if we want, we can remove the array notation, the array wrapper. So we have this without array wrapper. So now it's just objects one after the other without the array notation. So it's not an array of objects, just objects. Okay, so if that's what you need, you have support for that as well. So this is for the basic functionality for transforming relational to JSON. Let's continue. We have back to XML. We have for XML auto. This is maybe the most common one. Okay, I'm just changing it to auto. And now what for XML auto does, this is the first time we have truly hierarchy support. Okay, so now as you can see, we have a collection of orders, and within the orders root element, we have customer element. Within each customer element, we have all the orders related to that customer. So this is true hierarchy. Okay, and this is provided by the for XML auto. What for XML auto does, it goes by the order of the columns. Okay, so the first column is customer ID, comes from the customer table. So it creates the customer element, and within the customer element, it puts the customer ID attribute. This column order ID comes from the sales order header. So it's the second table in this query. So it creates a sub element in the hierarchy, a child of the customer, which is called sales order header, and puts the attributes there, and so on and so on. This means that the order of columns is important. So if I put customer ID at the end like that, it's going to look quite weird. So first we get the sales order header with all the attributes, and then as a child we have the customer related to that order, and then another order and the customer related to that order, and so on and so on. Okay, it doesn't look so good. So it's not what we meant. Also, the order of rows is very important, okay, because the XML is constructed based on the order of rows. So it's very important to put the order by clause. Here we use the customer ID and then order ID, which makes sense. But for example, if we order by the date and time, order date time, so we have hierarchy, but since it's ordered by the date and time, so first we get the oldest order. So we have the customer, the owner of that order, and then the order, and then another customer owning another order, which is the next one chronologically, and so on and so on. Okay, so again, it's not what we meant, probably. And just like for XML auto, we have for JSON auto. So it's the same idea. Okay, and the same note about the order of columns and rows. We have the external object with the customers key, and now we have an array of customers, and within each customer you have the customer ID, and we have another key called sales order headers, and now we have an array, a sub array of orders for that customer. So this is the first order, and here is the second order, and so on and so on. This is again true hierarchy, this time in JSON. Okay, so again I talked about the order of rows and columns, and that's it for JSON auto. Now I said before that for XML has 4 modes: row, path, auto, and explicit. For XML explicit is quite complicated and cumbersome, and I'm not going to cover it in this session. I will cover it in my session in Path Summit. But for JSON has only 2 modes, only for JSON path and for JSON auto, as we've just seen. So these are the only 2. We don't have explicit, and we don't have for JSON row. Now, till now, we just looked at how we can convert an XML, sorry, relational data set to XML or to JSON. And now let's create a table, a temporary table with an XML column and see what we can do with it. Okay, so I'm going to use a variable here. I'm going to put the resulting XML of this query with for XML auto into the variable, and then I'm going to insert the content of the XML variable into my column and my temporary table. So if we select from the temporary table, we have a single row, which is an XML that looks like this. Okay, let's leave it open. Now, since this is an XML data type, okay, the table here contains an XML data type, there are some things we can do with it. XML is actually a CLR type, so we can run some CLR methods on this type. For example, the value method. Okay, so I take the XML column and I perform the value method, and now I need to transfer an XPath expression, okay, where the value is contained within the XML document to extract, and the data type. This method extracts a specific value, a scalar value, and I must provide a data type for that value. So I'm not going to go into too much details about XPath expressions and XQuery and stuff like that, but I think you can get the idea here. This is the roots element, orders, and within it we're looking for an element called customer, and we look for the second customer element. Okay, so this is this one, this is the first, this is the second, and within the second customer element we're looking for a sales order header element, and the first one, okay, so it's this one, and inside that element we look for an attribute called order ID, which is this. So we're looking for that value, actually. This is what we want to extract, and it's going to be an integer. So if we run this query, we get the value we wanted. Okay, the result is a scalar value, in this case an integer value. Another option is to use the query method. Now value extracts a scalar value with a specific type. Query transforms the original XML to another XML using XQuery. So I'm going to construct a new XML. I'm going to construct the element orders here, and I'm going to close it at the end here, and within that I'm going to use XQuery. So for each order within the collection of sales order header, all the elements of type sales order header, each one where the order amount is higher than 50,000. Okay, so for example, here is one, here's another one, so on. So I'm going to filter only those that are above 50,000. For those, I will return an element order, a sub-element order, and within the element I'm going to put the attribute order ID and the attribute order amount of the original sales order header element. And the resulting XML is going to be like this. Okay, so we have the root element and we have a bunch of orders. All of them are above 50,000, and all we have here is the order ID and the order amount. It's just a simple example. We can do a lot of things using XQuery and transform one XML to another. The last, well, maybe not the last, but another method I'm going to show is exist. Okay, this is a method that returns true or false, and we just want to look for the existence of values or elements or attributes within the XML. So here I'm asking whether there is an attribute order ID with the value 45550 under an element called sales order header anywhere in the XML. Sorry, and the answer is yes. Okay, because it's there somewhere. Okay, here it is. So next thing is how to extract relational data, a relational data set from an XML document. So one option is to use the nodes method. Now because the nodes method returns a table, a complete table, we use it with cross-apply. So we select from the table and then we cross-apply to the nodes method. And for the nodes method, we also need to pass an XPath expression. Okay, so in this case, we want to extract all the sales order header elements as rows. So each row will represent a different element in the XML. And I will call this table orders, and the column will be called order row. Now this column is in XML representing a specific element. And now I can extract specific values from my order row XML. So this means go to the parent, okay, I go to the parent element and take the customer ID from there, and this means go to the current element, the sales order element, header element, and take the order ID attribute from there. And this will extract all the customer IDs and order IDs from the XML, okay, like that, okay, as a relational data set. Another option to extract relational data set from XML is to use the OpenXML function. Again, this was here since SQL Server 2K, and it goes like that. You need to declare a variable. You need to have a variable first which holds XML data. It can also be a text, by the way, and varchar, not only XML. So I'm going to select from the table and put it in a variable. And then we need a document handle. We need to call sys sp XML prepare document. What this system stop procedure does, it represents an inner representation of the XML in memory, and it outputs a document handle, which is an integer. And I'm going to use this handle in the next select statement, which uses the OpenXML function. So the OpenXML function returns a table. It receives the handle, and again, an XPath expression. Again, in this case, I want to look at all the sales order header elements. Another attribute, which means whether I'm going to look for attributes or elements, not very important right now. I'm not going to go into more details about this. And then I can specify the schema. Okay, so I want to return a result set that contains two columns, customer ID and order ID. The customer ID column, the values will come from the parent element, just as we did before, and the customer ID attributes. And for the order ID column, I will take the values from the order ID attributes. And we need also to remember to remove document, SP XML remove document, to release the memory. And then if we do all that, we get the same result as before, but with OpenXML, not with nodes. Regarding performance, in most cases, from my experience, OpenXML will perform better than the nodes method on a single value. But the nodes method has a very important advantage. You can use cross-apply. In our case, we only had one row in the table. But if you have a table with many, many rows, each one representing a different XML document, with cross-apply and the nodes method, you can return a single result set for all XML documents. You can't do that with OpenXML. You have to do some kind of iteration, and for each XML document, store it in a variable, call SP XML prepare document, and so on and so on. So it's not very convenient. Okay, now let's do the same for JSON. I have another temporary table, JSON, because we don't have a JSON data type, a native data type. We're going to use the nvarchar max here. And again, I'm going to run the query as before with for JSON auto, and I'm going to put the result in a variable of nvarchar max, and then I'm going to insert the JSON object into our table. And let's select from the table. Okay. Notice that now I cannot click. Okay, because this comes from a table where the data type is nvarchar. Okay, so SQL Server Management Studio has no idea that this value represents a JSON. Okay, while when we run this query here, because it says for JSON, it comes back as a JSON document. So in this case, SQL Server Management Studio provides the hyperlink because it knows it's a JSON. Okay, so this is an important difference. Let's just look at the JSON document, JSON object. Okay, so again, we have, as before, the orders external object, the customer ID, key values, sales order header, and then a collection of objects, and so on and so on. Okay, we've seen that before. Let's close some tabs here. Right, so the first thing we can do using T-SQL functions this time, we have the isJSON function, which receives as a parameter a text and returns true if this text is a valid JSON object or not. Okay, in our case it is. How nice. The next one is JSON value. JSON value can extract a scalar value similar to the value method of the XML data type, but this time from a JSON document or a JSON object. So it receives two parameters. First, the JSON value itself, the text value representing a JSON, and then a JSON path expression. Okay, so what we have here, first we have the word lax. This can be either lax or strict. Okay, like this. And what it means when you use LUX, it means JSON value is supposed to return a value, a scalar value. Okay, if this expression does not return a scalar value, and we use LUX, we're going to get null instead. If we use strict, we're going to get an error. This is what it means. The same goes for this JSON query. I'm going to talk about JSON query in a minute. But in this case, we're going to the root object. Okay, this is the $, and then we go into the orders. Okay, we need to have this back so we can look at it. There we go. Okay, so we go to the orders, and then we go, this is the first. Okay, we have an array, so this is the first object in the array, but there is one important difference between XML and JSON. XML, all the arrays are 1-based, and in JSON they are 0-based. Okay, so when I say here orders 1, it actually means the second. Okay, so we need the second object in the orders collection. Here is the orders collection. This is the first object, which ends here, and this is where the second object starts. Okay, so we're looking at this one, and then we're looking at the sales order header collection within it, and we go to the first object. Okay, so let's go a little more to the right. We have here the sales order header. Okay, I got lost. Anyway, whatever. Okay, so it looks for the sales order header collection, the first one, and within it we look for the order ID key, and it will return the value of that key. In our case, okay, it's the same value as we've seen before, but this time coming from JSON. And there is JSON query. Now, JSON query, compared to JSON value, will not return a scalar value. It can return either a complete JSON object or a collection, an array of objects. So in our case, I'm going to return an array. Okay, if we look at this, sorry, a specific object. Okay, the first object within the array. Okay, so here it is. And again, we have the LUX, we have the strict. If this expression does not return a valid query result, which means either a complete array or a specific object, if we use LUX, it's going to return a null value. If we use strict, it's going to return an error. We can also here return the complete array, not just a specific object, and then we have a complete array. This is also an option. And we can use OpenJSON, similar to OpenXML, but it's much better than OpenXML, because now we don't have to run the SPXML prepared document and all that stuff and use the handle. So it's more natively supported, and we can just use cross-apply, similar to what we do with the nodes method in XML. Okay, so now we can select from a table, cross-apply to this subquery, and within the subquery you can run OpenJSON. We just transfer the JSON value itself. We don't need the handle, the integer handle. And again, we need to transfer here some JSON expression path expression, sorry, and we construct the format of the table returned, similar to OpenXML. So we get all the values of order ID and order date time, in this case from a specific for a specific customer. Okay, the first customer. Give me all the orders of the first customer. Here they are. Okay. So much for the demo. This is how SQL Server supports both XML a long time ago and JSON now in SQL Server 2016. Let me go back to the slides and let's summarize, and then I will have some time for questions and answers. So we saw what XML and JSON are. XML and JSON are both standard, open standard. They are very, very widely used. XML have been around for many, many years. JSON is relatively new, but very widely adopted. They are mainly used for data exchange and for storing data and representing data. And there are all kinds of use cases, regardless of SQL Server, for using them, and mainly for representing semi-structured data, where we don't want, or we can't define the format and the structure of the data up front, and it can dynamically change over time. These are the main uses. SQL Server offers rich support, as we've seen. So we have the ability to transform a relational query, a relational result set, into XML document or JSON objects with using either for XML or for JSON, and there are all kinds of functionalities and options there. We can also transform an XML document into a relational data set. We can extract actually relational format rows from within an XML document or from within a JSON object using the OpenXML function or the OpenJSON function. We can also use the nodes method regarding XML data type. And specifically for XML, we also have a lot of functionality around the XML data type. We can use the CLR methods, as we've seen before. We can use XML indexes on XML columns. We can use namespaces. We can use schema collections for defining the schemas for XML. So there's a lot of functionality within SQL Server regarding XML on top of what we have for JSON. And of course, you need to consider and to appropriately use XML or JSON within SQL Server. Again, I've seen many cases where people use either XML or JSON where they shouldn't. So beware of that. But there are some use cases where you already work with SQL Server and you need to store some of the data as semi-structured data, and it would be more convenient to use an extra column in a SQL Server table rather than going to some other platform to do that. And again, every scenario is different and you have to consider. So this is it. Thank you very much, and I think it's time for questions.
Thank you very much, Guy. It was a wonderful presentation. I enjoyed it tremendously. And yeah, I think some of the attendees have the same feelings. There is a repeating question regarding whether you're going to post the scripts. So I know the recordings are going to be posted online on the 24 Hours of Past website. Do you know if the scripts are going to be available as well?
Yes, they are. I think they're already available in the 24 Hours of Past website, but anyway, I'm going to put it on my blog. So let me just, here, see information here, go to my blog, and I'll post it probably tomorrow. I'll post all the scripts and everything from this session.
Awesome, awesome. So yeah, we have some more questions. One of the first ones, when you mentioned MongoDB, Rinaldo asks, how do you integrate SQL Server with MongoDB?
Well, there's no native integration, but what I meant is when you develop your system, your application, part of the architecture is to use both Mongo and SQL Server. Some cases you might need to extract information from MongoDB into the application and maybe correlate it with some other information from SQL Server or vice versa. In those cases, it will be convenient to, in some cases, to transform the JSON object from MongoDB into SQL Server, for example, as a parameter to a store procedure. And then within SQL Server, you can do all kinds of crunching the data using JSON functionality in SQL Server. That's what I meant. I hope this answers the question.
I believe it does. Rinaldo also asks, one common question developer asks is that with NoSQL there is horizontal scalability, where in SQL Server there is not. What are your thoughts?
Well, in SQL Server there is also horizontal scalability, but not in the same way. This is why, again, what I said, that you need to choose the right platform. So if what you need mainly is scalability, working with semi-structured data, maybe SQL Server is not the right choice. Okay, so you need to consider. Again, I think that working with JSON or XML in SQL Server, it has specific use cases where in those use cases, the main reason is not because you need scalability or because you need to work with only semi-structured data. Use other platforms.
Great answer. Thank you. Itzhak asks, what about JSON validations versus XSD?
Well, this is one of the differences between XML and JSON. You don't have something similar to XSD working with JSON. You can do something similar, but there's no native alternative to XSD with JSON. We do have the isJSON function which just returns true or false for whether the text represents a valid JSON or not. But there's nothing that validates JSON against the schema in SQL Server, at least.
Thank you. Daryl asks, when, if at all, do you think the capabilities of Azure DocumentDB will make it into SQL Server properly?
Oh, that's a great question, and unfortunately I don't have an answer for that.
Yeah.
Not as far as I know, for now at least.
But this could actually be a very good question to ask at the PASS Summit. So
Absolutely.
At the PASS Summit, the CAT team, they do have the SQL Clinic where you can actually meet with the product managers and the developers and the executives on the SQL team, and you can just approach them and ask them these kinds of questions. And as long as it's not under NDA, I can guarantee you're going to get a very friendly answer. So
yeah, absolutely. Let me just add, for those who maybe don't know, Azure DocumentDB is a NoSQL database in Azure, provided by Microsoft, of course, similar to MongoDB and other platforms. It natively supports JSON, and it's offered as a PaaS, as a platform as a service in Azure. So it's a viable and it's a very interesting option if you need a NoSQL platform.
Okay, great. That's all the questions that I have so far, which I think, is a compliment to you, Guy. So it seems like everything was super clear. If you guys have some more questions, this will be a great time to ask. And if not, Guy, I think we have a couple of closing slides for the...
Okay, so we had questions.
Yes. Okay, Daryl also asks, what will you be covering at the summit that you didn't cover here?
Okay, so I'm going to talk more about the use cases, and especially in the demo, I'm going to show something that I didn't show here. For example, the for XML explicit and some other things you can do with the for JSON. So mainly around the demo. I have some more demonstrations that I would like to show. That there's not enough time here to show them.
Okay, great. So it seems that there are no more questions. So get ready, go take a break, a restroom break, go get yourself something to drink, because coming up is our dear friend Alan Hurt, who's going to talk about a closer look at distributed availability groups. Alan Hurt, if you know him, then, and you've heard one of his sessions, then you know it's going to be a lot of fun and very, very in-depth. Alan Hurt is a Windows cluster MVP, and he is Mr. Availability Groups.
Yes, he is.
Yeah, there's probably no one that is more familiar with the internal working other than the developers of how this thing works and how to apply it in real-world scenarios. So thank you very much again, Guy, and hope to see you all soon. And remember, tomorrow, either on Guy's blog, you're going to be able to download the scripts, and of course on the 24 Hours of PASS website. So once again, thank you, Guy. Thank you, everybody, and have a wonderful rest of your day.